Good afternoon, everyone. So thanks for your time this afternoon. So yeah, as Kao said, I'd like to talk about augmented reality and how we can use that to visualize information. Okay. So what I want to talk about, just a little bit of an introduction to augmented reality or AR. I want to talk a little bit about VR versus AR because there's still a lot of confusion about what the difference is between them. And then I want to talk about the capabilities and how it can be used by people. Okay. So I guess just to introduce Leap Australia, as Kao said, we're an engineering software solutions provider. We sell a range of different engineering software, which RMIT has a lot of. We've had a very long relationship with RMIT. Got quite a few RMIT graduates working for us. Hashan, you've already met this morning. So we sell, there's two main vendors. One is PTC, which is the side of the business that I'm on. So PTC is an American company based outside of Boston that's been around over 20 years now, basically providing, actually over 30 years now, providing CAD, product lifecycle management, service management, IoT and augmented reality solutions. Okay, so that's the side of the business I'm on. So I know someone came up and when he heard that I was from Leap at lunchtime, he said, "Oh, you must know ANSYS." I know nothing about ANSYS. Okay, so sorry about that. If you want to have any ANSYS questions for anyone from Leap, talk to Hashan. All right, and then ANSYS is the other side of the business. Okay. So that's ANSYS is the world's largest simulation software company, covering fluids, obviously of great interest today, as well as full multiphysics, so structural, thermal, electromagnetics, multiphysics, all the rest of it. Okay, and we also sell a range of other solutions around, primarily around simulation, actually, crash and blast simulation, materials handling simulation, injection molding simulation, things like that. Okay, that's a little bit about us, but what I really want to get into is about augmented reality. Okay. So what is augmented reality? So definition I like to use is superimposing computer graphics onto a live view of the world, also known as AR. So, I mean, who here has played with AR? Only a couple? Okay, maybe I'll talk a bit more and then you might change your mind, okay? So, augmented reality has been around a long time, okay? You may not know it, you might not think of it in this way, but AR is out there being used all the time. So based on that definition, superimposing computer-generated information on a view of the real world, the first real example of AR was a heads-up display. Okay, so the very first heads-up display went into service in 1960, British Buccaneer. Okay, so that's a long time ago. All right, for all of us here in the room, I think. Okay, so heads-up displays, obviously in military aircraft, they're available in civilian aircraft. You can get them in your car. Okay, you can get aftermarket heads-up displays, all sorts of things like that. Okay, and really an extension of that is your reversing camera display. Okay, so that's augmented reality, right? You have a camera that is showing you a real view of the world, but overlaying some digital information. That could just be a little grid showing you, how far away things are. Or the fancier ones these days will show you, sort of steering information to show you where you're going to turn, so you're going to make it into the spot. Okay, but really by definition, that is augmented reality. Okay. Other examples of AR, you watch any kind of sporting event, obviously the Melbourne Cup was on earlier in the week, okay, so they love all their little fancy graphics, and that's AR as well. It's really around helping you understand visually what's going on. So, we've got our swimmer here, she's swimming along in the final, and we can see that moving line showing where the world record is and where she is in relation to that, okay. Much easier to understand that visually just looking at the screen rather than trying to read a split time or a number up in the top corner, okay. If you watch the Melbourne Cup on Tuesday afternoon, which I think most people did, you saw when they're coming down the home straight, there's the 400, 300, 200 metre lines showing you how far away they are. That was all AR as well. That's not painted on the grass at Flemington. That's just some graphics to help you understand, where are the horses, how far have they got to go. Okay? So AR is really around helping you visually understand and process information. Okay? More recent examples, right? Our social media filters, Snapchat, Facebook, they've all gone crazy with all this sort of stuff. Don't know the real value of that, okay, but that's another example of AR, okay, that's quite widely used. So AR's been around a long time, and there was really a big, I guess, watershed moment in the history of AR that happened a couple of years ago that really brought AR to sort of the forefront of people's minds and made everyone really aware of what it was. Can anyone take a guess? What was the big AR thing about 2 years ago? Exactly, okay. Pokemon Go, right? That's AR, right? Very simple implementation of AR. You've got your smartphone, you walk around, location-based, look around, spot a Pokemon, and start interacting with that, okay? So that's a very, very simple use case of AR. And that, Pokemon Go was crazy. I think it was 60 million active daily users, numbers like that, okay? So it really sparked the interest in AR, okay? So that's a little bit of a history of AR, but let's talk about VR versus AR. So who's had a go at VR? A few more people, okay? So VR has been around quite a long time as well, and fairly well known. So things like the Oculus Rift, the HTC Vive, PlayStation VR, all of the Microsoft headsets that were released. It was last year, okay, for Windows 10 from Dell and Acer and Lenovo and all those guys. Lots of VR headsets around there. More coming all the time. Things like the the Pixmax 8K, which is about to come out, okay, or my favourite, the Google Cardboard, okay. Very complicated VR headset there. Okay, so these are all VR headsets, right? But the thing about virtual reality, it's all about immersion. Okay, so I put that on over my face and I don't see the real world anymore. I am immersed in the digital world. Okay, so they're great for entertainment. Gaming is why they've been so popular. That's really what's been driving VR for a lot of people. VR's been used in industry for a really long time for visualizing, training and things like that. But on the consumer side, it's really been driven by entertainment, gaming and the like, okay? So, VR is great. It has its downsides, okay? From an industrial perspective, one is that I can't see the world around me, which means then you've got to consider safety. I can't strap on a VR headset and go walking around a warehouse, okay? Because I can't see what's around me. Most VR headsets, usually there's a lot of photoshopping and editing of their pictures to get rid of that cable, but there's a cable that's usually running out from the headset tethered to something, a big PC or something, because to build that virtual world, I need a lot of compute power to do that. So there's usually a very powerful computer that's running that, okay? And so that limits the use. VR is great in industry. It's been used a lot for training. Okay, I've gone through various VR flight simulators, operational simulators. They're fantastic. They're great. You sit in the machine, you drive it in this virtual environment with your headset on, but I'm stationary. I can't get up and walk around and view information or do things like that, okay? And the other problem that VR tends to have is a lot of people get sick from using VR, okay? Due to latency, the fact that, your brain can't quite match up what's happening with what your body's feeling, things aren't quite right. So we get a lot of reports of that as well, okay? So VR's got its place, but really AR is, most industry people say that AR's got a much bigger market or prospect, okay? So augmented reality, this superimposing graphics onto the real world, okay? So really what's been driving that has been mobile devices, right? Smartphones and tablets. And I was like, who here in this room doesn't have a smartphone? Okay? So all of you have with you a device that is probably capable of doing some form of augmented reality in your hand right now, okay, or in your pocket, right? And that's really what's been driving AR to date, is this power, and they're becoming more and more powerful every time. Apple with the iOS kit, Google with the AR Core, doing all kinds of clever things with AR, okay? So these devices have really been driving the use of AR, but the future of AR lies in eyewear, okay? So, Google had a crack at this a few years ago with the Google Glass, which was really around just taking that information from something that I hold in my hand to putting it projected up here, above my eye line, okay? There are a few problems with that. The way it was pitched really was the biggest problem. It was pitched as a consumer device, so the problems around the expense of it, around concerns around privacy information with someone wearing a device could be recording, okay? Is someone paying attention to me? Okay, it's a lot easier to see when someone's picking up their smartphone and playing what they're talking to them rather than just staring at you through their glasses, okay? So it didn't really work. That being said, Google Glass has been recently relaunched as an industrial tool, okay? So things like these devices, these kind of, PTC likes to call them assisted reality, where we're really just taking that information rather than holding it in our hands, we're sort of projecting it up here in front of us, okay? So the Google Glass, the RealWear, HMT1 devices, then there's also augmented reality glasses. So rather than having that sort of sitting up there in a little viewport up there, I'm sort of projecting it in front of me in 2D, just something that's overlaid in front that I can read, like a heads-up display would do, okay? And then we're getting into more complicated devices that are really sort of placing 3D elements in the world in space, like the Microsoft HoloLens, or something that's been getting a lot of press lately is the Magic Leap 1, okay? So these are more complicated 3D, some people call them holographic devices, okay? So there's a lot coming down the track with AR, and you're going to see a lot more from it. You know, all of the big companies are right into that space. You know, Google, Facebook, Microsoft, Apple, all heavily investing in AR. They see a huge future in that. So it's a very exciting space with lots of changes happening over the time. All right. So that's a little bit about VR versus AR. But what I want to talk about is, you know, well, why would AR be of interest? You know, it's more than just Pokemon Go and, you know, vomiting rainbow Snapchat filters. Okay. So there's actual real use for this, okay? And really it's around what the capabilities that AR offers, okay? So they are really around visualizing information, around instructing or guiding people through processes, or maybe around interacting with devices, okay? So on the visualize side of things, okay, it's really, you know, what AR is all about, you know, taking computer-generated information and overlaying that in the real world, okay? So that could be viewing digital models. Okay, IKEA is a great example of this. Who's played with the IKEA Place app? Anyone? No? Okay. So IKEA's been doing AR for a really long time. Their latest version is this app. You go and download it. Pardon me. You look in your room and you can say, okay, what is this piece of furniture going to look like in my room? Okay, so I can see what it's going to look like. I can maybe check if it's going to fit, all those sorts of things. Okay. So, you know, AR has been used really heavily in sales and marketing by lots of companies for a really long time. Okay, there's tons of AR apps that are really just versions of their catalog to go and view, you know, their product in your home. Okay, but in terms of engineering usage of that, okay, we can view digital models, right? So this is an example. Stryker, big American medical company, is a PTC customer using their CAD and PLM solutions. They're using AR for helping design design operating theatres. Okay, so I can go into that space, show it at a small scale, zoom it up to full size, walk around that room and see what's going to fit, what's going to work in that layout. Okay. Case Western Reserve University. Okay, they're looking at AR as a way of teaching medical students. Okay, so rather than just some picture on a page, I can have some 3D model that I can walk around, walk inside, see it true scale. Okay, there's a lot more immersion in that. Okay, now you could do that with VR, absolutely. The difference with AR is that if I do this in VR, I don't just generate the model, otherwise I'm just standing in an empty white room like in the Matrix, right? There's nothing else around me apart from what I've generated. Okay, with AR, I can see that model standing here in the room next to me. Okay, you know, there are organisations like University College of London looking at taking, you know, medical scans and how they can produce them in AR. Okay, to let surgeons visualise what they're going to be looking at when they go to plan out a surgical procedure. Okay, so other examples, viewing CFD results. Okay, so this is something that that LEAP did with RMIT with the Formula SAE team to show an overlay of fluid flow results over the real vehicle to see how that's going to behave. And Hashan's going to talk a little bit more about that later on. Okay. We can use that to view not just models, but any kind of digital information. So that could be sensor data, okay? So, you know, there's a lot of talk about Industry 4.0 where I can look at a machine and I can start to view that information that I'm streaming off that machine through AR. Okay, I could take that, you know, in a medical environment, I could take that patient information, whatever it might be, and view that in other ways, okay? So really visualizing is one of the keys and probably what we're going to show today. But other examples, you know, instructing or guiding people through a process, okay? So, you know, how many of you read the manual when you open up the product? Okay? Most people don't. Some people do, but most people don't, right? There's a lot of time and effort goes into those manuals, but most people don't read them or they complain that they can't understand them, they're difficult, they don't quite match what they're seeing. So, you know, AR can be used to help guide people through a process in an environment that they're more familiar with, okay? I've grown, you know, someone who's grown up playing on their phone, playing computer games, okay, doing all these little things in AR through their social media filters and the like. You know, they're much more likely to understand and take to an AR experience to explain how to do something than they are to read a PDF file or a printed off manual. Okay, so Sysmex is a good example of this. A PTC customer that are using AR to create service instructions, pardon me, for their blood sampling machines. Okay, with the idea being that service techs or maybe even the customer could go and do initial service work on that, being guided through that process. Okay. Augmented, an Israeli company looking at actually producing AR guided instructions. So the surgeon is wearing, you can kind of see it up in the top there, wearing a pair of AR goggles to overlay that information to project down onto the patient, this is where you should be going. This is what where you should be, a 3D view of what they can see. So they can see what they can't see in AR, okay? Or it can be used for remote expert guidance, okay? So how many times have you called someone to ask them for help on setting something up, right? Happens a lot, okay? Usually it's my parents calling me how to get the DVD player working, okay? You've got to talk through that process, okay? So more and more companies, I've heard this from the service people, you know, what the service people are starting to do is like they'll do a FaceTime call, right? So rather than trying to describe what you'll see, you'll show them what you can see, okay? The next step beyond that is to use AR to then help us augment or overlay information on top of that. So I can be showing someone, they can be drawing on my screen so I can see, you know, what they're pointing out to me, okay? And there are examples of, look at this on a medical scale as well. So this is the STAR project being done by Purdue University in the US. The same sort of concept, okay? Where someone is going through a process, maybe it's a procedure. The example that this screenshot was taken from a video is you know, remote surgery and battlefield surgery, okay? So they're calling back to an expert who's guiding them through, this is where you need to cut to do this kind of procedure that you're not familiar with, okay? So guided AR to show through the process. And the last part is interacting. So as more and more products become digitally enabled, okay, they can be remotely controlled over remote sensors or remote systems, then we can also use AR as another way to manipulate those. So a good example of this is ThyssenKrupp elevators in the US. They've been rolling out Microsoft HoloLenses to their service techs with AR instructions. So the idea is that rather than having to go through a manual to do all this sort of stuff, it's all presented there in front of me. My job sheet, everything. I can just digitally mark that off as being complete and check things off as I go, okay? So that's also becoming more common. So really they're kind of the three main capabilities of AR around that: visualizing, instructing, guiding, and interacting, okay? So, you know, Sysmex is an example. I talked about them earlier. So, you know, it's really around helping improve, from an industrial side, if you're building equipment, improving productivity, okay? So, you know, their example was, you know, the problem was technicians were going out there, they didn't really know what to do, it was slow to diagnose a problem, bits were hidden, they couldn't really follow the instructions. You know, there's a lot of training goes into that. So using AR, they saw significant improvements in service time and uptime, okay? So what I'm going to show you, and if you want to have a play with this yourself, you can, is the product that we provide, which RMIT University does have, is called Vuforia Studio. And there's a free app that goes with that. If you search in the appropriate app store for Vuforia, you can download this Vuforia View app, okay, which I'll be using in a second just to show you guys how we, pardon me, how we visualize some AR information. The other one, the remote assistance, is Vuforia Chalk, so you can download those. If you just search the app store for Vuforia, they're both free to use, okay? There are commercial versions of them. The Vuforia View app is more around viewing AR. If you want to actually create them, there's some software you got to buy. But yeah, by all means, have a look at them and I'll show you an example of that, okay? So let's have a look of using AR to view information, okay? All right, get my screen sharing going here. Okay, so what I wanted to show you is an example of viewing information that's been created, overlaid on top of the real world. So this is something, Sean's probably going to talk more about the CFD side of it straight after me, but the idea of this is we've got this model here. You can see it's a 3D print off a 3D scan of somebody's face, not sure who, and then there's been some modelling done on the nasal passages in the back, okay? And some analysis done on that, which Sean will talk about, and really at this point we're looking at how we might view that information, okay? So obviously if you're talking about this with a real patient, you know, you can't just like turn their face around and see everything inside, okay? But we might have information from that from scans, so we can look at how we might overlay that information, okay? So there is, based on just on the face at the front there, I can start to see this digital information. I might just turn off the CAD of the face, so I can start to see the nasal cavity inside there, okay? And maybe we can turn that off and we can look at, Sean, you want to explain what this bit is, the ISO surfaces?
So they're just an ISO surface of velocity at a certain amount.
Yep, okay. So we've just taken that data out of CFD and projected that in AR to show that overlaid on top. Okay, we could maybe look at some of our, I think it's shear?
Velocity contours.
Velocity contours, sorry, yep. Told you I'm not an ANSYS guy, okay. All right, and then also based on the CFD, we can also look at, if I just turn this around a bit more, basically output pressures at these particular points. There we go, it's jumping around a bit because I've gone a bit too far behind, okay, to show what the pressures are at those points based on those results, okay. So this is just a very simple example of how we can use AR to visualize that kind of information, right? So if you have that digital data, okay, it's very easy for us to create an AR experience and place that in the real world. And really what that's about is helping people understand and visualize what's going on with that, okay? So that's really what I wanted to talk about, okay? I don't know if there's any questions at all.